Hello everyone, this is Vishnuvardhan Reddy Meda. On behalf of my team, I'm here to present our final graduate project for data mining tool, which is prediction of Bitcoin prices using deep learning, RNN, and LSTM algorithms. So, what is our project? The main aim of this innovative graduate project is to show how machine learning models can predict the price of cryptocurrencies if we give the sequential data and computational power. So we visualize our data using some Python modules like Matplot libraries. So it displays a graph with the predicted values of Bitcoin for the coming days. The most popular technology is the kind of technological solution that could help the mankind to predict the future events. Why? So the main concept was to implement a system which is capable to analyze the real-time data and give a sense of direction to investors to invest in the decision-making process. So our application will take some real-world data and will go through a series of data reshaping so that we'll get the data ready to be fed into the deep learning algorithms. So we'll use this data and predict the Bitcoin price for the coming days, like for the next 30 days or even more, and our model. So in the past, there were models which use machine learning algorithms to predict the prices of cryptocurrencies like Ethereum and Bitcoins. So what if there was another option? Like besides machine learning, there is another way to predict the price of Bitcoins. That is deep learning. So in deep learning, we can forecast the time series data. So modules. We use different modules in Python, like Keras, which is an open source neural network library, and Tensor. So the Keras is capable of running on top of TensorFlow backend and is designed to enable fast experimentation with deep neural networks. So it focuses on being more user friendly and extensible. And Pandas to provide the high performance and Matplot library to visualize the data to predict the values. So deep learning. Our project is made on deep learning, which is a subset of machine learning. Though it is a subset of machine learning, the main difference between both of them is deep learning uses neural networks. Now, what are the neural networks? Uh, Neural networks are the patterns of information. In neural networks, different patterns of information are fed into the network via the input units, uh, which trigger the layers of hidden units, and this turn arrive at the output units. As you see in the simple neural network, there are a series of data which are processed into the network, and you get the different output units. There is a hidden layer in between. So what is the difference between the simple neural network and deep learning neural network is that there are n number of hidden layers in the deep learning neural network, as there is only a single hidden layer in the simple neural network. Uh, when coming to time series prediction, neural networks are perfect for them. So as our project is entirely based on time series prediction, we here use a neural network algorithm called RNN, which is known as recurrent neural networks. So the capability of recurrent neural networks is that it memorizes the previous input when the huge set of sequential data is passed through it. Also, the problems with the recurrent neural network is that there is a long-term dependency problem. So So in big neural networks, we face the vanishing gradient and exploding gradient because of this long-term dependency problem. The solution to overcome with this long-term dependency problem in recurrent neural networks is that we use a special type of recurrent neural network that is long short-term memory. So a model, uh, we have generated Bitcoin data with supporting columns in the data set. Uh, the, then we have split the data into two parts for training and testing purposes, out of which 80% of data is used for the training and 20% of data is used for testing. And then we pre-process the data, like for the data is subjected to data cleaning. So in this process we remove the columns which we don't use. Then the data is scaled using scikit-learn's min-max scaler. Accuracy, how did we measure the accuracy in our model? So we have added more layers to LSTM model. These values can be changed as per the requirements. So as we adjust the values, the accuracy rate increases. Also, the accuracy rate depends upon the batch size and epochs. So to get the low loss, we can change the values of batch size and epochs. Lower the loss, higher will be the accuracy. Conclusion: much more could be done to improve the performance of our neural networks. Now, depending on how much time you took to train and tune the neural networks, your results may vary from ours. Uh, I uh, I can suggest to everyone that you can experiment with our code and test out different approaches to improve neural networks. There are just so many possibilities to explore with the deep learning concepts and new prospects as new prospects emerge every day. If you have any questions, you can comment under the YouTube comment section so that we can reply for everyone. Thank you.